Hi, this is Diana from DivineFractal.com. So, there is a very important reason I named this channel Divine Fractal, and I'd like to just get started explaining why. So, let's begin learning about fractals. Did you know fractals are ubiquitous in nature? And even if you did, do you know why they are? All right, let's take a look and we'll find out. 14 amazing fractals found in nature. Take a tour through the magical world of natural fractals and discover the joy of simple complexity. Here's a beautiful cutaway of a shell. When you think about fractals, I don't think about the Grateful Dead posters and the t-shirts. I don't know about you guys. What do you think about? Do you think about pulsating rainbow colors and swirly similarity? Fractals were first named after mathematician Mandelbrot back in 1975. And what they are a special set of numbers that display similarity through a range of scale. In other words, fractals look the same no matter how big or how small they are. Another characteristic of fractals is that they exhibit great complexity driven by simplicity. Some of the most complicated and beautiful fractals can be created with an equation that's populated with just a handful of terms. This is a gorgeous Mandelbrot set. One of the things that attracted me to fractals is their ubiquity in nature. The laws that govern the creation of fractals are found everywhere in the natural world. Pineapples, for example, grow according to fractal laws, and ice crystals form in fractal shapes. The same ones that show up in river deltas are actually the same fractals that show up in the veins inside your body. It's often been said that Mother Nature is a heck of a good designer, and fractals can be thought of as the design principles she follows when putting things together. Very interesting. We'll come back to that in the future. Fractals are hyper efficient, and they actually allow plants to maximize their exposure to sunlight and cardiovascular systems to most efficiently transport oxygen to all parts of the body. Fractals are beautiful wherever they pop up, and there's plenty of examples. So here are 14 found in nature. Oh, isn't that beautiful? Try not to fall into this close-up photo of Romanesco broccoli. Each of the smaller buds is made up of even smaller buds. And we can see some of that same fractal quality in these pinecone seeds. And in how this plant's leaves are growing around each other. Here's a block of plexiglass. Basically what they do is they expose it to a really high electrical current and it burns. And so this has a fractal branching pattern that's burned into it. Same pattern shows up all over the place. Here are some ice crystals forming. And at 20 times magnification, here are some copper dendrites forming. The pattern below was created by running electricity through two nails that are stuck into a piece of wet pine. And it's in trees. And it's in rivers. And in leaves. And in water drops, and even in air bubbles. Fractals are everywhere. A great example of how fractals can be constructed with just a few terms is my favorite fractal, the Mandelbrot set. Named for its discoverer, the Mandelbrot set describes a fantastic shape that displays amazing self-similarity no matter what scale that you look at it. All right, so here is actually a very simple equation. It probably looks complicated if you're not really into math, but it's actually quite simple. Z sub n plus 1 equals Z sub n squared plus C. So basically we're going to take just a couple of numbers and plug them in for the Z and the N and the C. I'm not going to get any farther into technicalities about that equation. There's plenty of places on the internet you can look them up if you're interested, and I'll include the link to this article in the description, and there's an infographic that's mentioned right here that you can go look at specifically for the Mandelbrot set. if you want to dive into it more specifically. But basically, what it means is if you take a complex number and you square it, and then you add itself to the product over and over and over again. You do it enough times, and then you translate those numbers into colors and locations on a plane, and you get beautiful fractals. So here's what I mean by fractals looking the same throughout the scale. This shows a zoom into a smaller region on the larger Mandelbrot set. Notice anything similar between where you start and where you end? All right, so here's a Mandelbrot set, and you can see where the arrow is there on the left-hand side. We're going to zoom all the way into that little tiny piece. All right, so we're going to zoom in, and we're going to keep on zooming, and we're going to zoom in some more, and even some more. All right, and so hopefully you can see that we've zoomed all the way into that little tiny piece, and we ended up with something that looks like what we started with, right? We'll scroll back up real quick. Check it out. All right, Mandelbrot set, right? And we're going to zoom into that little piece on the far left-hand side and keep on zooming and keep on zooming and keep on zooming. Isn't that amazing? All right, if you're really interested in that, you can see even more in a video that will be linked down below. Besides the Mandelbrot set, there are scores of other types of fractals. So here's a couple more that are really well known. The Koch snowflake. One of my favorites right here. This is the Sierpinski triangle. This is the dragon curve. Here is the Pythagoras tree. And here's the fractal tree. So which one of these is your favorite? Do you have any favorite natural fractals yourself? I'd love to hear about it. Please let me know in the comments below. And if you're liking the channel, please give us a like, subscribe, and share. This is Diana from DivineFractal.com. And until next time, please remember, be fearless, fill your heart with love, and create art. Love you guys.